Okay, so hi guys. In this video, we're going to be learning how to exactly integrate, and then we'll go on later in future videos on how to use it like in real life applications and exam style questions. So first thing we have to realize is integration is the exact opposite of differentiation. Yeah, so that makes it a lot easier. Let's say you had x squared. Well, it differentiates to form 2x. But going back, it forms x squared. So this here is integration, and this here is differentiation. So really, we just need to reverse the rules we use for differentiation and apply them to integration. Okay, so let's just go into that in some more detail with some concrete rules. All right. So, the first rule is that if you're integrating a constant, let's say that's called a. So wait, before I move on to how to integrate a constant, this scroll-like thing is the integration sign. And then the dx over here is just added at the end. It means it's with respect to x. So don't forget the dx or the scroll sign when like integrating something. It's just like a big S. All right, so when you're integrating a constant known as a, it just integrates to become ax, but that we don't stop there, plus c. Okay, so I need to provide some insight into why it's plus c. When you differentiate, let's say we had ax, right? And we differentiate it. It becomes a. So you might be wondering, why can't we just do the same thing in the reverse order? Well, the thing is, what if we had ax plus 3, like just as an example? When you differentiate that, that still gives you a. Which means if we have ax plus 19, ax plus 1 million, ax plus anything, which we refer to as c, it differentiates to form a. Therefore, this constant that we add at the end is referred to as c, like I've shown you in this equation. All right, so that's the first rule, just explained a little bit deeper. So for example, if you have 4 and you're differentiating that, that becomes 4x plus c, because it could be 4x plus 3 and it would still differentiate to 4. All right, let's move on to the second rule you need to know. So let's say you're integrating x. That would become plus c. Don't forget the plus c. The reason this is because in the power rule, it works like ax to the power, if you have ax to the power of n, when differentiating it becomes an to the power of an times x to the power of n minus 1. So in this context, if you had, let's say, x, right, it would be x to the power of 1. Since this is going minus 1, you would add 1. And since they drag it down first, you would first add 1 to the power before dragging it down. So it would go from x to the power of 1 to x to the power of 1 plus 1, which is equal to x to the power of 2. Then the 2 would get dragged down. So it would become x 2x. But since we're multiplying it here, we have to divide with integrations. It's not 2x. It would become 1 over 2x. And then, of course, we can't forget the power up here. So it becomes 1 over 2x squared. And just a side note, you can always check if you're doing it correctly by differentiating what you just got. So if you differentiate half x squared plus c, well, you bring this down. That becomes 2 times 1 over 2, which is just 1. And then you decrease this by 1, which is just x to the power of 1, which is x. So in this case, we have differentiated and integrated correctly. Well, integrated correctly, because that's what we're checking. Rule number 3. Let's say you had x squared. Well, if we can apply this logic, you raise this to the power of 3 because you increase by 1, and then you divide it. So that becomes 1 over 3 x cubed. It's the exact reverse of differentiation because the two can reverse to become the other. All right, let's move to rule number 4. This one's a little bit different. Let's say you have 1 over x. This would become ln of x and to the absolute value. So I guess the only way for me to explain this is that imagine you're differentiating ln x, right? That would immediately become 1 over x. So the reverse would mean it becomes back to ln x, and then obviously plus c. Now, I'm not exactly sure why it's in the absolute value, but just remember it is. I'm sure there's a reason that just I'm not aware about, but you won't need to know it for GCSE, so don't worry about it. Now, rule number 5. E to the power of x is still e to the power of x, but plus c. Because when you differentiate e to the power of x, it still becomes e to the power of x, so the two just remain the same when changing between them. However, rule number 6 is that if you have e to the power of 2x, for example, well, you would first need to integrate 2x. And 2x is basically, well, you don't need to integrate it, but you need to realize how e to the power of x works. So when we took e to the power of 2x and we differentiate it, that became 2e to the power of 2x. Because of this, we're going to need to divide by 2 instead of doing what we just did with differentiation by multiplying. So that would give us half e. And then obviously, when you have e to the power of anything, it doesn't really change. So it would still be 2x plus c. All right, so those are the first 6 rules. Let's move on to the next one. Let's say you have cos x dx. Now, we know from differentiation that sine x becomes cos x, and then cos x becomes a negative sine x. So, by that logic, we can really infer that if we're going from, if we have cos x, then it goes backwards to become sine x. And then that means sine x, or rather, if you look at this equation over here, let me just circle it. We can rearrange it we can divide each side by -1, which would give us negative cos x can become sine x, and then obviously we change the direction. So, by that logic, we've just answered 2 different rules. Cos x equals sine x plus c, and sine x is equal to negative cos x plus c. And you don't really need to know tan. Like, it hasn't come up much when, it hasn't come up at all for me during my period in the GCSEs. So I won't go into that. But just know that secant squared x becomes tan x plus c. Just because you need to know how to differentiate tan, and tan just becomes sec squared x. And you can obviously prove that with the quotient rule. So those are the main ones you need to know. The other thing you need to know is that when you add or subtract integrals, it still remains the same as differentiating. That, like, you can just subtract and add them normally. All right, so those are the main rules you really need to know for integration. You don't need to know them as thoroughly as, you don't need to know rules as thoroughly as differentiation. However, integration can be a bit confusing because it goes in the exact reverse of differentiation. But honestly, I find integration questions to be not that difficult because there are only a small number of applications you're expected to know at IGCSE level and a small number of rules. So in the next few videos, we'll cover the applications of integration and make sure we become masters at it. All right, so thank you so much for watching this video, and see you in the next one.